We're going to take a look at some mechanisms here today, so no electronics on this one. One of the things that has come up recently was a really small Lazy Susan, some sort of spinning mechanism that, for the particular problem we're trying to solve, it's for a user to put their heel on a base and to be able to rotate it. Now, I don't know all of the medical terms, I'm sorry, but that's the gist of it. Now, you could buy Lazy Susans in different sizes, and some of them are down to about 2 inches square. But one of the things I've done in the past that's worked out pretty well is repurposing a ball bearing, a roller bearing like this. This is a 608 style, and this is a very common size bearing. It's common because it's used for skateboards and rollerblades. So the nice thing about it, especially since they're used for skateboards, is they're very smooth, they're very strong, and they are usually available sealed. Now, by sealed, I mean that you see this black plastic here. It seals the bearings and protects the little metal ball bearings that are inside there. And while it could be used, and it could be used in either direction, either flat or upright. Usually it's like, I don't know what you would call this, lateral, but they're really pretty handy for that. So what I've done in the past, and I was playing around with it again recently, was doing some 3D printed parts where I could use this bearing to make my own little Lazy Susan. And this one is one of the final or semi-final versions of it. This is, let's see how big this is. I can't even remember. 30 millimeters square, but you could adjust the size as necessary. And I've got holes in here for M3 screws. But it's a two-part print. And the first part has where the bearing mounts. So the bearing slips onto this post and it's just press fit. And the other part of it is kind of the inverse of that. So it holds the outer edge. Now, when you're modeling these things, there's two things you want to keep in mind. The first thing is you need, and I realize it's black on black and it's hard to see. Maybe if I hit the light, it might help. Yeah. There is a little ridge right here. So this post is the diameter of the opening of the bearing. And then this flatter surface, which is only 0.5 millimeter tall, but is the width of going out to this metal edge, because the bearing works in two parts. You've got the center metal and then you have the outer. So what this does is it keeps the bearing from completely touching the base. So it's actually riding on the metal in the inside. And the outside is the same idea, where this hole is cut out so that it is wide enough so that it clears that inside part of the bearing. And again, it's pretty much just press fit, and these are strong, so you could use a little jeweler's hammer or a regular hammer and tap it together like that. And it holds together pretty well. Now, once you have the concept of that post and the lip and the outer circle, then you could integrate those into a larger design. You don't have to have these plates like I have here, right? These plates can be part of your design. And I have messed around with like having holes through the whole thing. This is an M3 hole through the center. But for strength, the best option for strength is to have that solid, because the weakest point, the weakest link, and this is an earlier one I had, you could see when I was trying to take this one apart, I broke the plastic part. It just snapped off at exactly the place I would expect it to snap off at. And this, I think this was printed with 100% infill too, so I wouldn't use the center hole if you don't need it, because that's reducing strength. But keep in mind, even still, this is going to be your weakest breaking point. Now, how strong is it? I was able to stand on one of these, and rotate, pirouette around like a ballerina, and it took the weight without any problem at all. These flat portions here are 3 millimeters, and this is in PET G. I would recommend probably PET G or nylon or something like that, something stronger than PLA, but PLA will probably be fine too, especially if you're really not holding the whole weight but just need a rotating surface. Because this whole idea of foot control, in addition to this project, has come up on a number of recent projects for me, because a number of foot controllers for gaming used to exist, aren't made anymore, and well, people still need them. So it's something that I'm revisiting again to figure out different platforms that will support the foot and allow them to do joystick control with foot and toe movement. So if you're looking for a little tiny Lazy Susan, maybe the answer is to print your own. And the other thing too is these bearings are all sorts of sizes, and so you could find bearings that are appropriate for your need. There are ones that are narrower, wider, all sorts of different bearing sizes. But the great thing about the 608s, they're super common, they're inexpensive, and they're usually very high quality.